Okay, I'm not on mute anymore. This is great. So yeah, I'll just get down to it. We're gonna look at some code, but it's not gonna be a ton of, I mean, it's a ton of code, but it's the same code over and over. So it should be easy enough to follow. Hello and welcome to Texas Open Data from soup to nuts. All right, let's do this. What is this? This is a Jupyter notebook running Rise. I used it like 2 years ago. I loved it. I want to use it again. So that's why it's going to be like this. So just letting you know, that's what it is. Okay, so the planning director at my last job really loved this phrase. So in her day, every meal was a full course meal. So you started with a soup, different types of soups, if you will. And of course, you ended every meal with pork and nuts. So personally, I think that Portuguese wine 3 times a day is a bit excessive, but I do love the idiom. So let's use it a bit. If you have not had the pleasure, let's have the pleasure together. This is the Health and Human Services website for childcare facilities. And this is how you do it, right? So I'm obviously not a fan. So I wrote an email to the state and I said, hey, can we not use this? Can we use a feature service or something else like that? And the backstory to this is that I had actually spoken to them 2 years ago and they said, hey, the state has this open data website, but we don't use it, but maybe we're going to, and then it just kind of died. So working under this assumption, someone at the legal department at the state got back to me and they said, hey, it's on the open data site, eat your heart out. So that open data site is great. It's built on the Socrata platform. So you may not have seen it, right? Depending on how expansive your shop is or not. So let's take a look at it together real quick. This is what it looks like, right? So if you wanted, you could download it, but it wouldn't be fun to do the button clicking stuff. So we're not going to do the button clicking stuff. You can see all the different types of columns and their data types. Anyway, so let's get back to it. So when I did this, I had never used the Socrata API, but it wasn't too hard to pick up. And because it was so easy to pick up, I thought, hey, let's present about it. So that's what we're doing here right now. So the things that I wanted to do were to bring it into the GIS, to download the stuff spatially, and to keep it up to date. So the Socrata documentation is really great. There's lots of horrible documentation out there, and there's lots of things that are just not documented at all. But it is super good. To get to it, right, you would go over to the API stuff and go to the API docs, but that's what this URL is here. And so what's really neat about this is that all of the examples are dynamic. So when you do stuff, it's to the actual data set. So you don't kind of remove that layer of like, oh, here's the sample data set and then try to match it to my stuff. All of it's dynamic, which is neat. So it's called the SODA API, which is kind of clever. And it outputs into different types, right? So if we go here, it goes from JSON, GeoJSON, or CSV, which is important for later. So if you wanted to click on the GeoJSON, this is what it looks like. It's a wall of dictionaries, right? It's a feature collection, and then each type of thing has its own stuff. Anyway, that's GeoJSON. All right, so we're not going to talk about this part, but this part is necessary to run, so it doesn't look horrible. This makes it look not horrible. You're going to see this. This is a convention for typing in pandas and GeoPandas. So when PD, think pandas. All right. So what we're doing here, the GeoPandas has a function called read file, which is super great. Not only can it read actual files, but it can ingest URLs. That's all we did, right? We just plugged in literally this URL into GeoPandas right here, and poof, spits it out, which is great. This is an F string. We'll use them throughout the presentation. Stop not using F strings because they're great. So you can see it's a whole data set. It's awesome. Here at the very end, we have a geometry column. It's point data. It's got some latitude stuff. Super great. And what's great is it's super easy with GeoPandas. But what's not great, and I don't know if you caught this or not, is that there's definitely more than 1,000 childcare centers in the state. Oh, yeah. So we could look at either of these things here, right? So we say, oh, there's 14.4 thousand rows, or in the API documentation, 14.425 rows. Okay, so there's more rows than what we had. So looking through the API documentation, there's a page on paging. So by default, the limit is set to 1,000. In the next release of the API, they bumped it up to 50,000. The release after that, they made it unlimited. So you can do unlimited stuff, but you might time out on you. So if you're working with big-ish data from the state, you might need to use requests. We don't need to for this, so we're not going to. So let's go ahead and rewrite the URL using a SOTA command of limit, $limit equals 50,000. And we'll just rerun the thing. And there's an artifact in here. It's kind of annoying, but I fixed it. You don't have to worry about it, but it's an issue. So data cleaning. Anyway, so here we go. Now there's 14,425 records in the data set as it's supposed to be. So super great, super lovely, really awesome. Also, that number is down here. So we have several options. We could use Fiona or GeoPandas. We could use ArcPy, or we can use the fancy, shiny new ArcGIS API for Python to write it directly to a feature class, which is what we're gonna do. So it has a different type of data frame implementation from the geo data frame in GeoPandas. It's called the spatially enabled data frame. So we'll figure that out and then we'll write it to a feature class. So here we do it. Right, it's really simple because there's a convenience function that Esri wrote, which is great. So all we have to do is call the function from geodata-frame, then we push our geodata-frame into it, and then out pops out a spatially enabled data frame. It's taking a little bit long to load right now because it has to load ArcGIS features. The ArcGIS package is kind of big, but once it loads, it'll be fine, and then we won't have to worry about it again. Okay, so here, data frame, just like before. But at the very end, you can see, boom, we have a shape column, which everyone should be familiar with. And it's got, you know, the nice Esri stuff with the spatial reference and everything, real good. So all that's left to do is write it to a feature class. And that is also super easy because there's a function for it. So we just write it to the feature class function. And the location is the place where the file geodatabase is at, and we're going to name it childcare. Yes, so we can look at that here once it loads. It'll load. I'm not worried about a live demo. Okay, there we go. There's the output. There it is. Okay. And I shouldn't be worried about opening it up in ArcGIS Pro. So let's take a look at it here once it opens. Heavy silence. Okay. Oh yeah, it's on my other screen. Great. Super. Not that you guys can see, but I can see. If you're wondering, I have practiced this presentation and I meant for that to be real awkward. So mission accomplished, in case you're wondering. Okay, great, here we go. So here is the childcare with a firefly look to it. And there's Texas, and there's more Texas and more Texas. And I think we're in a T-Mobile commercial. I guess. I don't know. Let's figure this out. So a little odd, I'm sure. Texas is big, and I was taught the best, but I don't think it's that big. Oh yeah, and all the fields are text fields, so we can take a look at that real quick. Now, okay, see, text all the way down, which is an issue, right? I mean, we don't want that. That's not good. So as a side note, the ArcGIS API for Python is real finicky when it comes to stuff not being just so. So you'll end up doing lots of data engineering. And if you accidentally write to a location like a file geodatabase, but you don't, slash it and make a feature class, it's going to overwrite your file geodatabase and it won't tell you and it doesn't care. So there's that. Be careful. But I guess the real takeaway is that anytime you do an ETL, there's going to be significant data engineering. 80% of what you're going to do is cleaning. So although we get to get a nice, somewhat sterile data set and it's going to work pretty well, if you're trying to make things that are value added, you're going to have to put in the work to make it value added. So closer to the nuts than the soup. We could have also looked at the data types using the geodata frame, calling D types. It says object. Object is the pandas speak for text. They now have text data types, but back in the day it was just objects. So what's happening here is that GeoJSON can be formatted with data types, but the way that Socrata is exporting it out is preventing that from happening. So if we look here for phone number, right? Because this is in quotes, GeoPandas is like, oh, it's a string, right? If it was not written in quotes, it was just a series of numbers, then it would come in as a number type. I don't know what number type it would be, probably an integer. But anyway, so your mileage may vary. Second, Pandas is super smart. It will interpret your columns automatically if it senses things of a type, right? It's great. It's used by everyone. So instead of manually setting all those data types or like trying to go through here and figure out like, oh, this one's a text and this one's a whatever, we can do it programmatically. That's what we're going to do right now. So let's do it. We are running Pandas, and Pandas has a read CSV function. Again, super cool. It can read files or it can read a URL. So it is just reading this URL right here. And then if you want to do Excel, there's a read Excel, but then you have to use an Excel driver and it's kind of annoying. So I normally just do read CSV because it's great. But here you can see data types, int64, float64, peppering the data set, which is good, which is what we want, Still, we got stuff like operation number, which is a string, and you're wondering why. But that's what the state's doing. So that's what they're doing. So we showed in the CSV that it came with the correct data types. Now the question is, how do we push those CSV data types to our GeoPandas data frame? And the answer is with a quick for loop. So what we're saying here is for every column in the CSV data set, we are going to we're going to call the column name of the geo data frame, and then we are going to force it to be the same type as the CSV column type. So that's good. And you should know what your errors are going to be. A general exception like this is lazy. So this is saying, hey, there's a key error. there's not actually a column called location address geo, and that's because we are getting rid of it because it's an artifact from the SOTA API. Well, not really the SOTA API. It's like because the data is not being filled out 100% correct on the state's end, but that's okay. And then here's our data types from our geo data frame. And look, they've got numbers, totally great. Everything's great, love it. Nope, that's not what I want. Okay, so that's done. So we've got it to have the new correct data types, which is neat. And then we're going to write it to our file geodatabase, right? That's what we're doing right here. So we're going to call it childcare with types. And oh man, what's this execute error? Oh, it's almost like I was expecting it, because you can't write to something that's open, and it won't tell you, hey, it's open, close it. It's just going to give you that nice mysterious error. So again, the ArcGIS API for Python would be great if it had some better error handling. So we close ArcGIS Pro, we rerun the thing, and then it works. It'll be good once it works. Boom, there we go, super. All right, so ideally, the SOTA API has this super cool bounding box function, right? So you make a square and you grab everything in the square. Oh, no, let's not do that. There we go. Okay, so this is actually where I started out. All those other slides, that was for your benefit. I actually was just geeked out and read through all the API documentation. I was like, oh, this is what I need. Let's start here. So I used bbox Finder because I didn't have my Esri stuff open at the time. It's real easy to make a bounding box here. That's what I did. Super, it was great. Anyway, so that's when I realized that, I mean, you saw, right? Everything's out in the US. So if you draw a box around Prosper, but there's stuff that's not around Prosper, then you're not going to get the number of childcare facilities that you should, right? So there are 21 in the data set, obviously more than 21 here in town. So you're able to see that pretty easily. So the SOTA API also super cool for specific data, but only really useful if you can query against it. So here we are saying where inside of the county column, this is a HTML for space, where county in colon or Denton, because we straddle the county line, which is cumbersome. And so we just rewrite the URL to be the URL plus the SOTA where clause, and then it does the stuff and it writes it out. Here it is, super. Now there's 10,086 records in the data set. Just totally great. Yeah, you could work with that if you wanted, but I don't want to because it's too much data. So we can make a workaround for it. And what we're doing instead is we are going to just throw all the data into a geodata frame and then say, hey, in this location address column, since it's a string, we're going to search for zip codes. So this is a regular expression, any of these zip codes that are in the location address column, because there's not a zip code column, there's just a location address column. Otherwise, we could have used the SOTA API, but we couldn't, so we didn't. This is, hey, these things, boom. So now we have 255 records for all of the childcare facilities that are in zip codes that intersect Prosper, which almost a fifth of the size, totally worth doing. So the other issue that we have going on here is the geocoder that the state of Texas is using, right? Now, the state of Texas has lots of resources available to it, an address layer, a 911 address layer, statewide parcels, whatever. They're paying Bing to geocode their data. So I'm assuming here that they don't have this in a GIS on their end, which is fine. It's fine. But what that means for us is that all the geometry is going to plop down on a street according to the address ranges, according to Bing, which is why you're seeing stuff all over the US, because Bing looks at the thing and it's like, oh, Wyoming, that makes sense. Or it's just not going to geocode and it'll be a table record. So what I'm using the data for is super specific. I'm making drug-free zones and sex offender living restriction zones. So I have two options here. I can try to roll my own geolocator, address locator, or I can maintain the geodata on my end and then update the state's data as a table record against it, right? So we keep the geometry that we put down on the ground and then just say, hey, give us the new refresh columns. So for a high value data set, I think that you ought to enforce some sort of quality control, which for me means foregoing the automated geocoder. Now, if the data velocity were higher, my answer might be different. But you know, you don't put up a daycare overnight. They tend to have some staying power. So we're doing this my way. And why wouldn't we? Okay, so what's going on here is we're just running a join, right? I don't know if you guys have ever run a join in GIS software or anything like that. But in Pandas, it's real easy. All we got to do is say it's join, the columns that we're using, how, you know, left or right. And then if you want to add some suffixes, so everything that's in the current data set, we're going to append _ prod to. So look at that. Prod, all the way. And then stuff that's not prod does not have anything appended to it. So easy enough. Then what we're going to do is we just want the updated data, but we want to keep the geometry. So assuming that I had just like drawn all that geometry in or whatever, what we're going to do is we're going to drop the states shape column here. We're going to rename the prod shape column to shape, right? So it looks like this data that's being updated. Then we will just drop anything that matches the expression _ prod, which is the attributes we want to update. So what we're left with is a data frame that is just a new state data with the old shape data that we're maintaining in our GIS. Then we reset the index because we should to export it. So it exports correctly. And then we overwrite our feature class. The overwrite's actually a default. You have to set it to false if you don't want to do that. And then it does the thing. So before I realized how long I was talking, I was gonna like go in and delete stuff, but we're not doing that. So let's pretend that I deleted some things. So anything where shape is null, right? It means it doesn't have geometry. So these are all just table records. And here they are. It's all the stuff in our data set that doesn't have geometry. So what would cause that, right, is if it's a new daycare that just popped up, then you would say, oh, hey, we can do stuff with this list and give it geometry. So kind of nice. That's the thing. That's the end. And also the question part, which is not the end. So here, you like, don't have any questions. So instead, I will say that I find this stuff fascinating. If you want to get a hold of me, I am holdable, I suppose. And even though we're meeting virtually, I have party favors for everyone. And those party favors are my script, because I'm a sharing kind of guy, and you shouldn't hide your bushel under a lantern under a bushel, something folksy. So there's a notebook, there's a YAML file, so you can do the same kind of cool stuff that I was doing. If you want to talk YAML, can. And yeah, there's a collab thing. It won't work in collab because you'd have to pip install it and stuff. But yeah, that's that. And I'm gonna look at the the questions and see if I can answer anything if anyone has questions.
Yeah, the chat's been quite active.
Oh, wow, look at those. How did Jordan become so awesome? Man, you know, it was being raised on Disney movies and then finding out that the world does not care about you. So you get a little jaded, a little angry. You don't hit the gym, but you hit the keyboard and start learning stuff. So if you're interested in learning stuff, I love talking about this stuff all the time. So anyone can do it. If you watch the Ratatouille with the rat that can cook, anyone can cook, anyone can code. I wholeheartedly believe it. So you just don't, it's not magic. Hopefully what everyone took away from that, the same like 15 lines of code over and over again, is it's not magic. It's pretty easy. You know, I mean, we all do the magic map stuff all the time. So there's that. Let's see, Tor. Looks like it's coming down fast enough not to need to filter by date, so that you can overwrite any current data without having to filter by date. Is this the case? Yes, for the child care centers for the state of Texas, because there's only 14,500. However, the second part, part two to this presentation would be, what about all those records of actions, right? It's not enough to know that there's a child care facility. We want to know, like, do they beat the kids or whatever, you know, whatever the state inspects when they inspect. So the inspection records, there's a lot of those. And then, yeah, you'd probably want to filter by date. They also have several unique keys inside the data set. So you could say, hey, if this unique key exists, then don't do it. But again, all of that is a lot easier to deal with inside Pandas than inside of the SOTA API. So grabbing everything out and then doing the data cleaning, the data hygienics would be the way to go for that. But yeah, if it's more than 50,000, you could have issues with timeouts. So you'd want to just use the requests library and put that in a for loop and say batch it by the object ID or something, or their unique key, and do it in batches of 50,000 or something, and then push all those data frames together, probably is what I would do off the hip. Let's see. F strings, yes. Oh man, you should use F strings. It's so great. Inside the brackets, it actually will compile the stuff, right? So you can do more than just like, oh, what's the variable? You can call like the variable type, or you can do mathematics inside of it and stuff. F strings are super powerful, and they have the added benefit of making your code more readable. You don't have to see like, oh, variable dot format and then all those variables. Oh, that's gross. And then people use other stuff that's even worse than that. F strings are great. They're in Python 3. If you're not using Python 3, you need to be using Python 3. If you're stuck using Python 2, you can import future and use F strings. So it's a win-win for everyone and for F strings. Oh, that's it. That's it.
All right, any more questions, anybody? Okay, cool. All right, thank you, Jordan.
Thank you. And thank you, State of Texas, for taking open data seriously. I appreciate it.